Okay, let's unpack this. Something genuinely transformative just happened with the devices many of us carry around all day. The iPhone in your pocket, the iPad on your desk, the Mac you work on. They just became incredibly powerful, intensely private supercomputers. It's a fundamental shift, really.
That's precisely it. And it's all thanks to, well, a new approach to integrating artificial intelligence directly into the core of the operating system.
Right. So the big idea here, the core strategy Apple unveiled at their recent Worldwide Developer Conference is
Yeah,
what? Putting powerful AI models on your devices.
exactly. It's a deliberate choice, prioritizing your privacy and personal context, all that data living locally on your phone or computer, over sending everything off to the cloud.
Which has been the dominant model until now.
Pretty much. This really redefines what personal means in personal computing, especially now with AI.
And in this deep dive, our mission is to guide you through understanding that shift. We pulled together everything, the technical white papers, feature breakdowns, competitive analysis, the works.
Yeah, we're going to jump right in.
We'll explore the genuinely cool, sometimes almost magical things you can now do with this on-device intelligence. Then we'll peel back the curtain.
Look under the hood, yeah.
Exactly. See the impressive engineering feat required to make powerful AI run smoothly on your phone or laptop without it, feeling like it's going to launch into orbit or drain your battery in minutes.
Absolutely. And we'll spend quite a bit of time breaking down Apple's big story around security and privacy, how they're trying to keep your data safe.
Including that new private cloud compute thing.
Definitely. And what this all means for developers, how it stacks up against Google, Samsung, Microsoft.
Right. And then the real-world impact. What does it actually change day to day? Plus the limitations, of course.
And maybe a final thought on what's next. It's a comprehensive picture of this new era of personal on-device AI.
So let's get into it. Why this on-device right now approach? Why the sudden shift?
Well, you only have to look back a couple years, really.
Yeah.
We all saw the incredible rise of cloud-based AI chatbots and assistants.
They were everywhere.
They exploded onto the scene. And they showed the sheer potential of generative AI understanding language, creating images. It was amazing. A real proof of concept for what was possible.
Right. But then came the realization and maybe a little bit of discomfort for a lot of people.
Exactly. As users started interacting more deeply, feeding them sensitive documents, asking personal questions, translating private messages, a very significant concern emerged. Data privacy.
Yeah. Where's my stuff going?
Precisely. People started asking, where's my data actually going? Is it being stored, used for training? Who sees it? This growing awareness led to what you could definitely call a privacy backlash.
Against just sending everything out into the ether.
Yeah. The promise of AI was exciting, but the traditional cloud model where everything travels to a remote server, it felt inherently uncomfortable for our most personal information.
Our photos, private chats, health data, you name it.
Exactly. People got genuinely excited about AI capabilities, but that was quickly tempered by the realization that feeding your sensitive context into a system you didn't fully control felt risky.
So that created a demand, right, for AI that respects personal space.
A powerful demand. AI that understands and processes your sensitive info without that info leaving your device. That user demand plus tech advancements set the stage for a different approach. Bring the AI to the user's device.
Run the models right there where the data lives.
You got it.
And Apple is uniquely positioned for this, aren't they? Because they're hardware.
It absolutely boils down to their long-term investment in custom hardware. This isn't something they just decided to do overnight.
No, they've been making their own chips for ages.
Over a decade. And a key, often underappreciated, part of those chips is the neural engine. It's not just a standard processor. It's dedicated hardware engineered specifically for machine learning tasks, super efficiently.
The neural engine. I feel like I've heard that term, but it's suddenly front and center now.
It's been in their chips for a while since the A11 back in 2017. But back then, it was for simpler stuff like face AI or image processing. What's changed now with the A17 Pro chip in the iPhone 15 Pro and the M series chips in iPads and Macs is the sheer power. The latest versions have a 16-core design, trillions of operations per second. That leap is what makes running these much more complex AI models practical on the device itself.
So it's been quietly getting stronger in the background, and now is the engine making this level of on-device AI possible without killing the phone.
Exactly. Think of it like this. Running a big AI model on a regular phone CPU is like hauling a semi-truckload with a pickup. Slow, inefficient, burns fuel like crazy.
Right, not ideal.
The neural engine is like a dedicated, optimized engine built just for AI loads. That 16-core NPU in the A17 Pro, 15.8 trillion operations per second. That kind of power, plus the efficiency of Apple's chip design, is essential.
So it can run complex AI stuff in real time without overheating or draining the battery instantly.
That's the goal. It's the hardware foundation that makes sophisticated, privacy-first, on-device AI practical now.
Okay, that sets the stage. User need for privacy meets Apple's custom silicon capability. Now, the fun part. What does this actually mean for me? Using an iPhone or Mac? What cool new features pop up?
This is where it gets really interesting, because Apple hasn't just added like an AI chatbot app. They've woven this intelligence throughout the entire OS.
So it feels more intuitive, less like a separate tool.
That's the idea. Your device just got smarter, more helpful, almost naturally.
And some of these sound genuinely futuristic. Real-time translation during calls. Seriously.
It almost feels that way. We're talking system-wide real-time translation powered by these on-device models. Imagine texting a friend overseas in a different language.
What?
You type in English, and as you type, it can just automatically appear in their language on their screen, and the reply instantly translates back to English for you.
Whoa. Live translation as you type in a private chat.
Exactly, and it goes beyond messages. FaceTime calls, even standard phone calls. The system can show live translated captions popping up.
So you can follow along visually.
Right, while still hearing the original voice. Or it can even use a synthesized, translated audio voice to speak their words aloud in your language, like a discrete, real-time interpreter.
That's amazing. And the crucial part is it's on-device, private.
Absolutely crucial. The translation happens locally using Apple's models. Those personal conversations aren't sent to some cloud server where they could be logged or intercepted. Privacy is key there.
That's a massive game changer for communication. What about making devices smarter about what we're seeing on screen?
That's visual intelligence. It builds on existing stuff like visual lookup identifying plants or dogs in photos, but expands hugely. It lets you understand and act on anything visible on your screen.
Anything. Photos, documents, live screen.
Yep. The easiest way in is via the screenshot buttons. Take a screenshot, and besides the usual options, you get invited to explore it with Apple Intelligence.
Okay, so it's like asking my phone, hey, understand these pixels.
Pretty much. Say you see a photo of a lamp you like online. Screenshot it, tap Explore, and ask in natural language, what lamp is this? Or find similar ones online.
And it analyzes the image locally.
On device. Using its integrated vision capabilities, it can tell you about the object using local knowledge, offer to search the web, or even connect to specific apps you have, like Etsy, if they integrate.
And it gets smarter with context, like event flyers.
Yes, that's
Yeah.
a really clever use case. If you screenshot an event flyer, concert, fair, whatever, visual intelligence can spot the date, time, location automatically.
Oh, nice.
And then proactively suggest adding it to your calendar, pre-filling all those details. No manual typing. It saves steps, anticipates needs.
And again, that analysis happens locally unless I choose to search online or use another app.
Exactly. Screen content stays private by default.
That's incredibly smart. Feels very seamless. What about writing? We spend so much time typing.
Apple Intelligence becomes your personal writing assistant, woven into text fields, system-wide notes, mail, pages, Keynote, even third-party apps potentially.
How does it work?
Select any text sentence, long email, and access the writing tools. Core functions. Rewrite, proofread, summarize.
Is this just a fancy spell checker then?
Goes way beyond that. Sure, it helps with grammar and style, but the describe your change option is powerful. Select a paragraph, give it instructions like make this a polite apology, or rewrite this note formally, or give this a poetic tone.
And the AI tries to match that style.
Using its understanding of language, yeah.
Right.
And crucially, your text doesn't leave the device for this. Early testers found it super handy for refining drafts, though maybe a bit inconsistent interpreting subtle requests initially. Apple's been improving it, though.
And summaries. That sounds like a lifesaver for long email threads.
Absolutely. In Mail and Messages, a summarize button takes a long thread or group chat and condenses it. Gives you the gist, the key points, without scrolling endlessly.
Also on device, keeping emails private.
Yep. Saves time, helps you catch up quickly, all privately.
What other little bits of AI magic are tucked in, especially in Messages?
Messages get some neat AI-powered suggestions, like if you're debating dinner spots in a group chat, it might detect that and proactively suggest creating a quick poll right there.
Oh, okay. That's useful.
And for visual flair, Genmoji backgrounds. Using Image Playground, which we'll get to, you can generate custom chat backgrounds based on the conversation. Talking beach vacation. Generate cartoon waves.
Speaking of Image Playground, that sounds like it's all about creative stuff.
It is. Yeah. Image Playground and Genmoji are tools for generating images and emoji-like stickers from text prompts. Yeah. Genmoji, type dinosaur in a tiny hat, get a custom sticker.
Fun.
Image Playground is more elaborate. Mix themes, costumes, places, even use your own photos as a starting point, with prompts to create unique visuals for messages, notes, whatever.
But image generation, isn't that usually cloud-based? How does that fit the privacy story?
Good question. Apple's very transparent here. For simpler stuff, basic Genmoji, default styles, and Image Playground, it's all on device. Fast, private. Yep. However, for advanced styles like oil painting or pencil sketch, it can use external models, specifically OpenAI's, via a secure API.
So it does go to the cloud sometimes.
But, and this is critical only with your explicit permission, the first time you ask for an advanced style needing an external model, it pops up, asks if you're okay sending that request data out. You have to opt in.
And it asks every time.
That's the indication, yes. It keeps you in control. Default is private, on device. Option for more power with full transparency and consent.
Got it. What else in the creative space? Photo cleanup?
Yep, photo cleanup. Like Magic Eraser elsewhere. Easily remove unwanted objects or photo bombers with a tap or brush. There's also Image Wand, turns rough sketches into polished images. Useful for diagrams in notes. Plus, memory movies. Type a description movie about our mountain vacation, and AI selects relevant photos, videos from your library and makes a mini slideshow.
And this intelligence even made it to the Apple Watch.
Yes, with Workout Buddy, a real-time AI-driven personal coach for your workouts.
How's that work?
It uses the on-device AI on the watch and paired iPhone, analyzes your live data, heart rate, pace, history to generate personalized feedback during the workout.
Not just text on screen, though.
No, this is the cool part. They built a unique generative text-to-speech model for it. It speaks encouragement in a natural fitness plus style trainer voice.
Seriously?
Like you might actually hear, based on your pace, quarter mile to beat your PR, keep pushing, or heart rate suggests you could increase intensity slightly, dynamically generated.
Wow, that sounds motivating. And private. Health data stays local.
Absolutely. All processing for Workout Buddy stays on your device's watch or offloaded to the paired iPhone for heavier tasks. Health data isn't sent to the cloud for analysis.
And rounding out the new stuff for 2025, AI call screening and hold assist.
Yes, more integrations for everyday tasks. AI call screening likely uses on-device smarts for better spam filtering or giving context about callers based on recent interactions, all local analysis.
And hold assist. That sounds useful.
It does. Probably uses AI to understand hold music, tell you when a human's back, maybe even estimate wait times better based on audio cues, making annoying phone interactions smoother with local AI.
Okay, fantastic overview of the user features. It feels like AI subtly enhancing the whole OS. But now, let's go behind the scenes. This is the deep dive. How does an iPhone actually run a powerful AI model? Let's get into the engine room.
Right, this is where the impressive engineering really shines. At the heart is Apple's in-house foundation language model, the core AI brain designed specifically for efficiency on your device.
So what size are we talking? Not the massive trillion parameter models in data centers.
Not at all, and that's deliberate. The main on-device model is about 3 billion parameters. Still large, but orders of magnitude smaller than cloud giants like GPT-4 or big Gemini models.
Like that size.
Engineered specifically for the constraints of edge devices. It's transformer-based, like many state-of-the-art models, but custom optimized for Apple Silicon right down to the architecture.
And they did something specific with the architecture to make it work on a phone.
Yes, a crucial detail for user experience. They split the model's layers into 2 blocks during inference, about a 5-to-3 layer ratio.
Okay. Why split it like that?
Not random. It significantly reduces the memory needed and speeds up the time to first token.
Time to first token. How fast it starts answering.
Exactly. The latency before it starts generating. By splitting it and reusing memory between blocks, they cut peak memory overhead by roughly 37%. Helps it fit and feel much faster, more instantaneous.
Clever. A specific tweak just for phones. Beyond text, you said it understands images too. Multimodal.
Yes, key for a device AI. Unlike many smaller text-only models, Apple's is multimodal, understands both text and images, produces text. They trained a dedicated vision encoder alongside the language model.
A vision encoder. Like a mini AI just for looking at pictures.
Good way to think of it. a specialized component trained to interpret image content. On device, it's a 300 million parameter vision transformer adapted from Apple's existing vision models.
And that's what lets it see screenshots for visual intelligence.
Exactly. Or read text in images. It uses a mechanism called register window to grasp both tiny details and the overall picture efficiently. Tailored image analysis, compact enough for your device.
Makes sense. And language handling, understanding long conversations or documents.
Designed with a relatively large vocabulary for its size, 150,000 tokens. Bigger than many comparable models. Helps it handle 15-plus languages, emoji, symbols natively.
In context window, how much can it remember?
Impressively long. Up to 65,000 tokens.
65,000 tokens. What does that mean practically?
It means it can process and remember a very long piece of text, dozens of pages worth. Critical for on-device tasks like summarizing long articles, analyzing lots of notes, understanding long email threads. Uses interleaved attention to manage this.
Interleaved attention.
Yeah, it alternates focus between local parts and the big picture of the whole document. Helps maintain understanding across long inputs, where smaller models often struggle.
And the training data. Apple's been clear. No private user data or Siri recordings, right?
Absolutely explicit on that. No private user data used to train their foundation models. Instead, they use a broad, curated data set.
Like what?
Licensed data, public data sets, and a massive web crawl by Applebot, their own crawler, used for Maps and Spotlight. Hundreds of billions of pages, filtered for quality and safety. Publishers can opt out, standard practice.
And visual data.
Extensive. 10 billion image-text pairs from the web, 175 million docs with images and text, even 5 billion synthetic image captions to enrich visual understanding.
So the goal wasn't an internet trivia bot.
No, the goal was tuning it for tasks useful on your device. Understanding structured data, coding help, summarizing multilingual tasks, not obscure facts.
How did they actually build and fine-tune it?
Combination of techniques. Teacher-student distillation was key. They trained a larger teacher model, more complex on high-quality data.
And the smaller on-device model learned from that.
Yeah, through distillation. Helps the smaller model absorb the larger one's capabilities efficiently. They also trained a separate, much larger model for their private cloud tasks.
What about the stages? Text first, then vision.
Right. Initial text training, then added vision by aligning the vision encoder, then joint multimodal training for handling combined inputs. Plus targeted training on domains like code and long documents.
And making sure it's helpful and safe, like we expect from AI now.
That's where fine-tuning and alignment come in.
Yeah.
Techniques like supervised fine-tuning, SFT, giving it examples of desired inputs-outputs, multilingual vision tasks.
And reinforcement learning from human feedback, RLHF.
Yep. Human raters evaluated outputs for helpfulness, harmlessness, accuracy. Fed that feedback back to improve behavior iteratively. Used an automated GPT-4 judge, too. Crucial for making it behave appropriately.
Including different language nuances, British versus American English.
Exactly. Tuning for locales, cultural references, RLHF significantly improved quality. Also focused heavily on tool use, teaching it to call external functions, important for developers.
Given all that, how does this 3B model stack up capability-wise? Can it write a novel?
Important to set expectations. Apple's clear. It's not a GPT-4 competitor for general world knowledge. Its optimization is for tasks involving personal or contextual data on your device.
Notes, photos, messages, what's on screen.
More precisely.
But within its class. 3 for 4 billion parameter models.
Apple claims it performs very favorably. Internal benchmarks show it's competitive or outperforms others like Qwen 2.53b, Gemma 3.4b on various tasks.
Even in vision.
Reportedly, the 3B model plus its vision encoder outperforms some larger 4B vision models on certain benchmarks.
So the takeaway is state-of-the-art for an edge device. Optimized for personal tasks where cloud models have privacy issues.
Exactly. It's not trying to be the biggest brain on the internet. It's trying to be the smartest, most private brain for you on your device.
That makes sense. Tuned for your world. But even 3 billion parameters sounds big for a phone. How'd they get it to fit and run efficiently?
Here's really impressive engineering. Aggressive memory compression and quantization, the big one. Compressing model weights to just 2 bits per weight.
Hold on, 2 bits per weight. That sounds tiny. How can you store AI complexity with so little info? Doesn't that wreck accuracy?
Sounds counterintuitive, right? Like packing a library onto a postcard. You need clever compression, yes, but more importantly, smart compression during creation. It's called quantization-aware training, QAT.
Meaning?
They don't train a full model, then squish it. They train it knowing from the start it'll be 2 bits. It's like writing that library for the postcard format, choosing word structures differently so it's still legible and useful when compressed.
So training with the limitation minimizes accuracy loss.
Exactly. Compared to squashing a fully trained model after the fact, they also use other tricks, 4-bit embeddings, 8-bit KV cache for intermediate calculations, and they train small adapter models after quantization to restore quality.
And the result? Huge accuracy drops.
Apple reports only minor drops, sometimes even slight improvements on certain benchmarks after quantization and adaptation. It's pretty remarkable.
So with all that compression, roughly how much memory does the core model take up?
Ballpark. A 3B model at 2 bits is maybe 0.75 gigs, plus overhead for embeddings, cache, vision encoder. Likely 1 to 2 gigabytes total. Significant, but manageable on devices with 8 GB plus unified memory.
Unified memory helps too.
Big time. CPU, GPU, neural engine efficiently sharing the same fast memory pool. It's part of the Apple Silicon advantage.
And the neural engine that makes it run fast, not just fit.
Absolutely. Fitting is one thing, speed and efficiency is another. The MQU is purpose-built for ML acceleration. Apple uses advanced techniques optimized for it.
Like speculative decoding and context pruning. Simple terms.
Sure. Speculative decoding. Imagine the main 3B model thinking. While it thinks, a smaller, faster model guesses the next few words. Main model checks the guess. If right, much faster than generating from scratch, like a fast predictor helping out.
Okay. And context pruning.
That's for efficiency with long inputs, like summarizing a long email chain. The system might intelligently spot irrelevant parts, footers, disclaimers, maybe old off-topic bits. Context pruning lets the model ignore or de-emphasize those, focusing compute power on the crucial info.
Got it. So NPU power plus these tricks makes it fast.
Right. Offloading calculations using speculative decoding, context pruning, all accelerated by the NPU, 15.8 trillion OPSEC on A17 Pro, reduces load on the main CPU-GPU. That's why you need the A17 Pro or M1 Plus chips.
They have the NPU power.
Exactly. Result: near real-time performance for many tasks. Rewriting a paragraph in a second or two feels as fast as a cloud API, but it's local.
Hardware power, software optimization making it fit, run fast, but running an LLM is intense. How do they stop the phone getting scorching hot or killing the battery?
The ongoing challenge. Primarily, offloading to the super power-efficient neural engine helps a lot. The 3NE part process in A17 Pro helps 2 smaller transistors better efficiency.
And the OS manages it.
Plays a crucial role. Likely limits run duration for tasks, chunks bigger jobs, dynamically adjusts performance based on temperature. Apple also reports increased NPU inference efficiency year over year, more AI compute for the same power.
So the promise is, it shouldn't feel like it's destroying your battery for typical tasks.
That's the goal. For continuous stuff like Workout Buddy, those features are tuned to be very lightweight, stay within thermal limits even during long workouts.
Reassuring. And how do these models stay up to date? Are they static?
No, definitely updated. Foundation models, or more often the adapter layers tuning them, get updated via standard OS updates, like features rolling out in minor iOS 18 updates after launch.
So Apple can improve the AI through software updates.
Right, and we can expect major OS releases, future iOS, macOS versions to potentially bring improved foundation models too.
So the intelligence evolves. Okay, let's shift to what Apple frames as maybe the most critical aspect, privacy and security. With AI processing personal data, how does on-device actually protect it?
This is Apple's core promise, their key differentiator. The principle is simple but powerful. On-device processing means your data stays yours. Private emails, notes, photos, conversations processed locally by the AI on your device.
So for most features, data never leaves.
For the vast majority, correct.
And that's the direct contrast to cloud-first AI, where your query and data travel across the internet.
Exactly. With cloud rivals, queries, documents, photos go to remote servers, get processed, maybe logged. Apple designed Apple Intelligence explicitly to protect users' privacy at every step.
Even live translation for calls.
Yep. Models run on the neural engine, data exchanged device to device. Apple servers aren't involved in listening or translating private calls. This local processing also enables personalization without uploading sensitive data. The model learns your writing style, contacts, photo types, all on device.
Making it smarter for me, but that knowledge stays put.
Precisely. Your AI gets smarter about your world, but that knowledge remains securely siloed on your device.
What about federated learning? Does that play a role?
Apple uses FL Elsewhere keyboard, maps for aggregated learning without raw data. They have infrastructure for federated evaluation tuning for these models, hinting at possible future privacy-preserving improvements from anonymized feedback.
Using differential privacy, maybe, adding noise.
Likely. But they're clear. not using user interactions from Apple Intelligence to train the core cloud models. Any future learning would be under strict privacy conditions. The personalization, like Siri understanding context, happens via local reasoning on your data with permission.
Okay, but no on-device model is all-powerful. What if a query is too complex? Does it ever need the cloud?
Yes, absolutely. Sometimes you need more compute power or broader knowledge. That's where private cloud compute, or PCC, comes in. Apple's innovative solution for cloud power with privacy.
Private cloud compute. Sounds like a contradiction. How's it private?
Sophisticated system. Think of it as a secure, temporary processing booth in the cloud, summoned on demand. Your device determines a query needs PCC, encrypts the relevant data locally.
Then sends it. Where?
To specific Apple PCC servers. Not a persistent farm, it dynamically provisions a temporary dedicated instance just for your request. Encrypted data goes there, gets processed, results sent back. Critically, the server is architected not to store your data long term. Does the job, then designed to immediately delete it. No logs, no retention.
And how can I be sure it's not secretly saving my data?
Cryptographic verification. Your device, using the Secure Enclave and Secure Boot, checks it's talking to a genuine Apple PCC server running approved, auditable code that doesn't store data.
Auditable code. By outsiders.
Apple-stated independent auditors can inspect the code to confirm it meets privacy promises, no logging or retention. Unusual transparency for cloud infrastructure. PCC extends the privacy ethos to the cloud when needed, securely, temporarily, verifiably.
That's a remarkably thorough approach. What about external models like ChatGPT? Siri taps into that.
Yes, Siri has a tiered approach, on-device first. If too complex but Apple-related, maybe PCC. Finally, for broad knowledge or complex creative tasks, it can integrate with third-party models like OpenAI's GPT-4o.
So crucially.
Only with explicit permission.
Siri won't just send my stuff to ChatGPT without asking.
Absolutely not. User consent is paramount. First time it needs an external model, it pops up, asks if you're okay, you opt in, and it asks permission every single time afterwards.
And there's an agreement with OpenAI.
Yes. Stating data sent via this integration cannot be stored or used by OpenAI for other purposes, like training. Apple's reportedly covering basic usage costs too, no OpenAI account needed, and data isn't retained for that basic use, so it's a flexible hybrid. Most tasks, fast, private, on-device, controlled, verifiable PCC when needed. Powerful external model only when necessary, with consent and safeguards.
And if third-party apps use these AI features via the foundation model's framework, do they get access to all my data?
No, not at all. Apps still operate strictly within standard app sandboxes and privacy permissions you've already granted. AI doesn't bypass security.
So an app only feeds the AI data it can already access.
Correct. Model was also trained with filtering to avoid problematic content, aligned via RLHF for safety. Apple relies on that upfront work and App Store rules, holding developers responsible for their app's output and data handling.
So the core message,
Yeah.
Privacy by default, local first, controlled and opt-in for anything leaving the device.
Exactly. Defaults to the edge, uses unique hardware, leverages controlled, ephemeral cloud, PCC when needed with safeguards, clear transparency and choice for external services, directly addresses cloud AI privacy concerns, positions Apple as a leader in privacy-first AI.
Okay, user experience, tech deep dive, privacy covered. Now the ecosystem. What does this mean for developers building apps? How can they leverage Apple Intelligence?
Big move here. New tools, primarily the Foundation Models framework, a Swift API giving developers access to the on-device LLM and other AI capabilities within their apps.
What can devs do with them?
Integrate core AI, summarize text in-app, extract info, names, dates, classify content, sort feedback, generate text contextually, all locally on the user's device using Apple's model.
And you mentioned guided generation, using it generable.
Yes, this is huge. Developers define the exact structure they need the AI output in, like a Swift struct for a meeting summary, with fields for attendees, action items, points.
And the AI outputs exactly that structure.
Exactly. @Generable tells the AI, read this transcript, output the summary structured like this. Model is constrained to that format, makes AI output reliable, predictable for use in code, solves a major headache, also includes built-in tool calling. Devs define custom functions in their app, fetch weather, get calendar, that the AI can intelligently decide to call to get real-time info or perform actions. Seamless integration.
And all the summarizing, extraction, guided generation, tool calling free for developers.
Yes, huge benefit. Since it's on-device using Apple's models, no per-call API costs like Cloud AI. Massive difference. Lowers the barrier for devs wanting AI features, especially using private user data. Works offline, too.
Can you give a concrete example beyond basic summaries?
Sure. Election Notes app. Select a transcript. Ask, extract key action items and owners present as a structured list. Guided generation ensures the output fits the app's data structure. Or a recipe app importing from photos use multimodal AI to see text, extract ingredients instructions into structured fields.
Yeah.
Privately, on device, Day One uses it for smart journaling prompt summaries, all trails for suggesting hikes based on preferences privately. Huge potential for any app with user-specific content, productivity, creative, health.
What if a dev wants to use their own model, open source maybe?
Still possible. CoreML, Apple's long-standing framework, is still there. Foundation Models likely uses it underneath. Devs can bring their own models, Llama, etc., to CoreML, optimize them, run them.
But using Apple's model is easier.
More appealing, yeah. Already optimized for Apple Silicon, licensed for use, integrates tightly with new framework features like guided generation, tool calling. Less heavy lifting for the developer.
Interesting that Apple's also using AI to help the developers themselves in Xcode.
Key part of building the ecosystem. Xcode 26 has deeply integrated AI. A coding assistant suggests code, fixes errors, helps with documentation.
Flexible how? Uses ChatGPT. Local models.
Both. Can use ChatGPT. Apple might cover basic costs, no key needed. Can run local models on the Mac for privacy with local code. Devs can plug in their own API keys too if needed.
And it understands the code context.
Yep, context-aware actions, inline natural language prompts, write code to do X. Clear signal, Apple's boosting developer productivity, not just adding end-user AI, like GitHub Copilot.
How do these dev tools tie into system AI like Siri and visual intelligence?
App Intents framework enhanced for visual intelligence. Third-party apps can contribute results when users ask about screen content. Example, use visual intelligence on an object. Etsy app, if installed, could show relevant products alongside web results.
Seamless integration.
Right, and Siri's better context understanding helps it handle third-party app commands via App Intents more effectively too.
So Apple provides the core AI tech. Devs leverage it for smarter, integrated apps without cloud costs complexity. What are the rules or limitations for devs?
Standard App Store rules apply. Manage resource usage. Abusive AI could hit performance battery. Must respect user privacy permissions and sandbox. AI content must meet guidelines. No harmful stuff. Crucially, if sending any data to an external cloud AI, must disclose clearly, likely get consent. And Apple nudges devs towards on-device for personalization, discourages uploading user data just to train models. That learning should happen locally.
Makes sense. How does Apple's developer offering compare to Google, OpenAI, Meta, Microsoft?
Some convergence, distinct approaches. Apple and Google are now quite similar, easy-to-use APIs for on-device AI, summaries generation, free per use, offline. Google has Gemini NanoML Kit Gen AI for Android, analogous to Apple's foundation models.
Contrast with OpenAI.
OpenAI powerful models, GPT-4, but cloud-only API, paid per token, data leaves device. Essential for max intelligence cases, but cost privacy implications. Apple, Google now offer a compelling, free, private, local option for many app tasks.
Meta, Llama.
Meta focuses on open source. Devs can run Llama anywhere, including mobile, but running it efficiently on mobile is hard work for the dev quantization, memory management, integration. Much more effort than using Apple, Google's optimized models frameworks.
Microsoft.
On Windows. Currently more cloud-centric. Promotes Azure, OpenAI, Copilot integrations relying on Cloud GPT-4. Local inference via Windows AI is emerging, but less central than Apple, Google's clear, free, on-device model offering. So Apple has really productized its AI model as a core platform feature for developers. Compelling, private, cost-effective local option, easy integration, likely to spur a wave of AI apps on iOS, macOS leveraging personal context.
Paints a clear picture. Moving to broader competitive analysis, how does Apple Intelligence stack up against consumer AI from Google, Samsung, Microsoft?
Fascinating comparison. Each plays to strengths, different philosophies. Apple, Google, most similar. Integrated AI blending on device and cloud. Samsung's Galaxy AI, also hybrid. Microsoft's Copilot, heavily cloud-weighted, for now.
Let's compare with Google first. Apple Intelligence versus Gemini Nano Android AI.
Core concept similar. Small local models for summaries, generation, screen context, plus cloud options. Google has Gemini Nano on Pixel 89, some flagships, ML Kit APIs for devs. Key difference now. Likely reach and integration.
How so?
Apple's is tightly integrated, OS-wide, consistent hardware support. A17 plus M1 plus on many recent devices. Google's building it, but Android fragmentation means Gemini Nano isn't on most Android phones. Apple has an early lead deploying integrated on-device AI across a significant user base due to hardware-software control.
What about Samsung's Galaxy AI? Heavily marketed.
Also hybrid on-device translation, cloud for other features. But Samsung doesn't have its own foundational LLM integrated system-wide like Apple Google, often bundles partner tech. Features like AI photo editing, live translate exist, but sources suggest Apple's tight integration gives features like visual intelligence photo search an edge in reliability and capability, reportedly crushing Samsung's equivalent sometimes. Vertical integration wins consistency.
And Microsoft's Windows Copilot feels very different.
Fundamentally different philosophy. Apple, DEDGE first. Privacy first. Deep personal context. Microsoft, cloud first. Power first with Copilot relying on Cloud GPT-4 via Bing. Copilot, mostly offline useless, sends data to cloud by default. Local AI on Windows PCs with MTUs is starting, but not as central or deep as Apple's on-device push.
So Microsoft leads in general cloud knowledge, Apple in personal, private, on-device tasks.
That's a fair summary.
So Apple made a very deliberate trade-off.
Yes, absolutely. Conscious choice. Traded some breadth and general world knowledge of giant cloud models for the huge benefits of local AI. Privacy, speed, seamless integration with your personal data and device context.
Optimized for personal tasks, not trivia.
Exactly. Their 3B model is optimized for analyzing your notes, photos, messages, screen content, not being an all-knowing oracle. It's personal intelligence.
How does this privacy-first on-device approach fit the evolving AI regulatory landscape?
Significant area where Apple's choices might help. EU, US developing rules on AI transparency, data governance, privacy, often focus on how companies collect, process, use user data. By doing most inference on device, Apple drastically reduces instances where sensitive personal data leaves, gets processed centrally, stored long-term. Sidesteps many compliance headaches faced by cloud AI providers handling massive data sets on servers. Aligns well with GDPR, maybe high IP and health. Potentially, yes. Since personal data often doesn't leave for core features, it aligns well with strict privacy laws. Could make Apple Intelligence easier to use where data localization is key. Governments might view this edge-first architecture more favorably, less sensitive citizen data floating in third-party clouds. Apple isn't immune, but their design philosophy positions them strongly.
Let's bring this back to the user, the real world. What does this actually change day to day? And what are the current limitations?
Everyday life goal, smoother, more efficient device interactions, accessibility gains from live captions, productivity from zero-weight translation, instant summaries saving reading time, quick writing help, automated tracking reminders surfacing info without digging.
And it does this without killing the battery.
That's the aim. Efficient MPU power management techniques are designed so AI tasks don't cause excessive drain or heat. Should feel like a natural energy-efficient extension, not a power hog. Siri also benefits understanding context better for device tasks.
Okay, the upside. Limitations. Can't be perfect.
No system is. Obvious one. Model size. 3B on-device isn't GPT-4 for broad knowledge, won't write research papers or answer super obscure questions reliably. Siri defers or uses external models, opt-in for that. Optimized for personal context, not universal trivia. Occasional inconsistencies too, especially early on. Writing tools, interpreting nuanced creative prompts might need editing sometimes.
And the biggest limitation for many, hardware requirement.
Absolutely. Most significant barrier now. Needs A17 Pro, iPhone 15 Pro Max, or M-series chips, M1 Plus and recent iPads Max. All older iPhones, all Intel Macs miss out on core on-device features, need recent high-end hardware.
Also user discovery. Features are subtle.
Potential limitation. Blended into UI screenshot flow for visual intelligence, text menus for writing tools. Some users might not realize the full extent. Apple uses Tips app, etc., but takes time to explore. An initial rollout limited by region language, though expanding.
Okay, let's bring it all together. Core achievement and a final thought for listeners.
The core achievement is profound. Apple fused custom silicon, advanced software models, and deep commitment to privacy into a powerful, personal AI layer. Not a cloud chatbot. It makes your devices smarter for you, respecting your personal space and data, processes your context notes, photos, messages, screen locally to provide personalized help without sending info elsewhere. PCC handles edge cases securely, ephemerally. External AI interactions are strictly opt-in with protections. Quietly but fundamentally changes interaction with personal tech.
Truly redefines personal computing in the AI age. Shifts the conversation from cloud AI to AI living with you on your device.
Exactly. Which brings us to a question for you, our listener. As AI gets deeper into your daily tools, phone, computer, watch how important is it to you that the intelligence assisting you, understanding your personal context, lives primarily on your device.
Or are you comfortable with it and the data it needs, living mostly in the cloud? What's your personal appetite for truly private AI? It's a question Apple's approach forces us to consider, and one that will shape our tech future.